Hello guys, you're welcome back to our class again today. In this particular experiment, we are going to be bringing you the light demonstration for your 2023 WAEC examination for physics practicals. Remember that in this instruction, we're told to provide a triangular glass prism, a plane mirror, then plain sheet and a drawing board, thumbtacks here, and then a pin, an optical pin. Confusingly, you were asked to provide a block, a rectangular block made of glass or perspex. For me, my interpretation is that we are going to be using the triangular glass block, but using this as a support for the mirror by the side. However, you can also prepare for it to be this with the mirror at the back with this as a support. But I believe that this is what the experiment is all about. So what is the procedure we're going to do? First of all, you're going to trace the outline. Here is already, I've done one here. Trace the outline of this block, and then you must have your protractor. Usually when you're starting with lower angles, you start with the angle closer to A, as you can see here, labeled ABC. So start with your angle closer to A. You can see here, I have it. Balance it on the balance it on the block, as you can see, like this, and then tap your 90 up and down to make your normal. When you must have done that, don't remove it at once. Just with this, the first angle according to the instruction you're seeing there would be 20 degrees. So you just do all the tappings at once. Just tap your pencil at 90, tap also down part of it, and then count 20 degrees from 90, which will give you 70 here, and then you tap the 20, so that you just do the drawings at once to maximize time. When you must have done that, then we'll put 2 pins along the lines and then view from the other end. So let's show you how you can be able to do this. So this is my drawing, as you see here. This is my normal and this is my incident ray. Now once you are drawing it, don't stop here, just produce it at once so that you can have a straight line, and it is on this line that we are going to actually put our pin. So the angle here, the angle of incidence for this particular experiment is 20 degrees. You can actually write it on top here so that you will not mix it up, and then put your 2 pins, give them a little bit of a space, and then replace your block for viewing. So here is the final outcome of my setup. You can see my pins here, my 2 pins that I used initially, and then here is the block. The mirror is also positioned with the block here supporting. Then once the ray is refracted through the triangular glass prism, it is now reflected through, so that it will now undergo total internal reflection through the glass prism, and then emerging from this other part, that is the AC part, and then you can now use 2 other pins to obstruct the ray. So once that is achieved, such that all these 4 pins will align in a straight line, once you achieve that, then good. So at this point, what we are going to do is now to remove all of this. Now that we have finished this, remove this. Now we are going to trace this line to pass through the block to make contact with the incident ray, so that we can find the angle of minimum deviation, or whatever they call it. They can call it theta, whatever, and then we'll measure the emergent angle, and then some other angles that may be asked of you by the examiner. But take note that you can do well to use your protractor to measure whatever angle that you are asked to find. Okay, this is the values I've gotten from my first experiment. For I, 20 degrees, I got my theta here measured at 74, and the angle of emergence. For measuring of the angle of emergence, there won't be, I would advise you not to bother drawing the normal. Just place this and use your 90 line as your normal. Once you have placed it, just count from 90 to this point. Anything you get is your angle of emergence, so that you don't waste your time. This exam is time bound, right? So that's why you did not see the line for the normal here. So I'm going to proceed to replicate this for angles other than I equal to 20. So I'm going to draw again and do for 25, 30 up until 50. So this is the setup for the second experiment. You can see I had already measured my angle to be equal to 25. I've inserted my pins and replaced the block on the outline, placed the mirror beside it, and then of course the rectangular block supporting. So I'm now going to view from the prism from this end and see these two pins, and then use other two pins to replace them, and then I'll come back to measure it for you so that we'll observe and know what the trend will be like. So here is it. I've been able to replace the pins. You can see I've traced the path from the block itself, that is after reflection from the mirror, and here are my two pins I have used to replace them. So all of them are aligned in a straight line. So I'm going to dismantle the setup again and then trace the points before measuring to find out what my angle would be. So let us see what we're going to get. Okay guys, after measurement, this is what I got. My theta to be equal to 67 degrees and my angle of emergence E equal to 27 degrees. Now, when you compare it with the first result, you can see that theta is expected or is observed to decrease and that E is observed to increase. We're going to confirm this by the time we do the third one, and we know whether it is consistent with this trend that we have observed now. So what we have also done in number 1 and 2, I'm going to replicate that again by doing number 3 for I equal to 30 degrees, and let us see whether we'll get exactly the same thing. All right, so you can see that I have drawn, also made my measurement for I equal to 30, and I have also placed my two pins, and they are erect as it is here. I have successfully replaced the block on the outline that I drew initially, and I have placed my mirror and the block to support as usual. Just a simple note of warning: just avoid the mirror to be so closed or to lean on the glass prism. If you do that, it would sometimes, it is not that it is compulsory, it may affect the position of the glass prism. In other words, pushing it out of the outline, and that will present you with a wrong result. So just make it to lean on the block itself, that is outside, such that it will not be exactly on the glass prism, triangular glass prism, so that it will just be safe to remain in its outline. So I am set now to view, so you can see what I'm saying. So in this case, just take it out and make it to stand on its own. Ensure that the block is on its outline. So this is exactly what I'm trying to avoid, but this is it. So I can proceed now. I'll trace from, ensure not to trace from the mirror, trace from the block itself. So I'm set to take the reading now, and then I'll show you what the measurement is shortly. Here is my tracing. So I'm going to now draw to measure the angles, and then we'll do the comparison. So I'm free to now remove all of this, remove this, and then so let me trace and check back what the answer will be. So let's do the comparisons. Here's what my result is. I is 30, theta is 50, and then E is 38 by my measurement here. If we compare it with what we have, you can see that it is consistent with the trend, right? Just that the E is a little bit, the value is a little bit farther away, but it is understandable. That's why it is a prism. So when we plot the graph, we will see how it looks like. So I have two more to go, 40 and 50, and then we'll see what the result will be. So here represents our eye for 40. I've already done everything, the measurement, the tracing. So what is left now is for me to get the values of theta and E. I just wanted to show you how the pins are being placed. So I'm going to dismantle this as usual and then measure. Once I draw my line, I'll find my measurement. So this is what we have here. You can see the angle theta is 42 and even the E coincidentally is also 42. So if we run a comparison check on all of them, you can see that there is a progressive decrease in theta, 74, 67, 50 and 42, and then there's a corresponding increase in each, 25, 27, 38, 42. However, we still have one more experiment to do, and I believe that that should also correspond with what we have so that our graph will be very neat. So let's just complete this experiment. I will show you what the graph looks like and of course the theory behind all of this experiment. So finally I have the tracing here for the last one. So let us see what the readings is going to give. I'm going to still do as usual, measure out what the angles are and then we'll compare. So in summary, this is what the drawing is. You can see that consistently my as the eye is increasing, my theta is decreasing and then my E is increasing. So this is what I have. I am going to compile this in a table, use it and plot a graph. Definitely we are expected to plot a graph of theta on the vertical axis and E on the horizontal axis, starting both axes from the zero origin. So once I do that, I would show you what the graph looks like, do the slope, and then answer so many other questions that are connected to the graph and of course the practical itself. Stay tuned. Okay guys, now having performed the experiment together, here is my trace. I've shown you my trace paper. So my trace you can see here. Then from here I can now compile my table, and this is what my table looks like. You can see the angle of incidence I that I used is recorded there, 20, 25 to 50, and then theta that we measured in the experiment, which was in a decreasing trend, has also been captured on my table, and then the angle of emergence E, which was in an increasing trend, was also captured in my table. The serial number, of course, is necessary to guide us. And then with this, we are asked to plot a graph of theta on the vertical axis and then E on the horizontal axis. Using that, here is what my graph looks like. So I have here a graph of theta on the vertical axis and then E on the horizontal axis. This is a straight negative graph as it is here, of which if we were to find the slope, I got a value of minus 1.85. Now, the intercept on the vertical axis for this my experiment is 119. Recall that in this experiment, you're expected to take the precautions of ensuring neat traces, avoiding error due to parallax in reading the protractor, and then ensure that your pins are erect when you are taking this reading. There are some few questions you may be asked during the course of your exam. Some of them are what I am going to expose you to, although it is not limited to what I have been able to put together here. There are more questions that could come. All are dependent on your examiner. One of them would be to explain total internal reflection. Note that total internal reflection of an incident light is the reflection of an incident light at the interface between the medium of incidence and another medium of lower refractive index when the angle of incidence in the denser medium exceeds the critical angle. Now, you can also just simply say it is the complete reflection of a light ray within a medium. In this medium, we can say it's either a glass, water, and air. Another question will be that they can ask you to state the conditions for total internal reflections to occur. There are basically two conditions, one of them being that the light must move from a more dense medium to a less dense medium. Number two, the angle of incidence must be greater than the critical angle. These are conditions for total internal reflection to occur. They can also ask you to define the term or explain the term critical angle. The critical angle is simply the angle of incidence in the denser medium when the angle of refraction in the less dense medium is 90 degrees. Going further, they can say state examples or they can say applications of total internal reflection. Some of them include the mirage, optical fiber. They can actually just ask you to state, they can actually ask you to list, they can actually ask you to explain. There are many, the fish's eye view, and all of those are all examples and applications of total internal reflection. Because of the plane mirror, they can ask you to state the laws of reflection. One of them being the incident ray, the normal and the reflected ray all lie on the same plane. And then the second law is that the angle of incidence is equal to the angle of reflection. Then here we have a question. They say, if a narrow beam of white light is incident on a triangular prism, what will be observed when the emergent beam is incident on a white screen? Now, you know that upon entry of the white light at the boundary of the triangular glass prism, there is a slight separation of the white light into its component colors, or what we call a spectrum. Upon exiting the triangular glass prism also at the second boundary, the separation becomes even greater and the dispersion component colors of white light are being observed in details. That is the Roy wave. Here we have a question: with the aid of a diagram, explain the difference between the reflection from a plane mirror and the reflection from a sheet of blotting paper. Now, a plane mirror is a smooth and polished surface. That is why we have a regular reflection. So this is what we have it here on the left hand side. And then for a sheet of blotting paper, is usually a very coarse, rough surface. So it gives us an irregular type of reflection, and this is how it can be represented. They can ask you to differentiate between deviation and refraction. Of course, you know that refraction is the bending of a wave, or you can say it's the change in speed of a wave at the boundary separating two media of different densities. Now, for deviation of light occurs when a beam of light changes route as it travels from one medium to another medium. And here we have what is meant by the statement the refractive index of a prism is 1.5. It means that the ratio of the speed of light in a vacuum to the speed of light in a material is 1.5. Or it means that light travels faster by 1.5 times in vacuum than it travels in a medium or in a material. Then finally, they can ask you some few calculation questions like involving critical angle. Remember that refractive index is equal to 1 over sine c, where c is the critical angle. Or they can also ask you to explain or solve mathematical problems ranging around minimum deviation. Also note that the refractive index is equal to sine A plus the minimum deviation over 2 over sine A over 2. Now the A there represents the refracting angle of the prism. And then in direct format, the angle of minimum deviation is also equal to 2I over A, in case that is what you're given and asked to find it in that regard. So these are just few sample questions that could come up. Now there are varieties and wide range of questions that you can experience in this particular, in this particular experiment. But I've given you this just to give you a framework of what to work with and just to show you. And then I believe that with this, that you can have the confidence to approach your exam whatsoever. And I so much believe that with what we have done so far, that is going to give you a good footing going forward into your examination. So I wish you all the best, and I know that this is going to be of help in a great way. Thank you for watching. God bless you.